Welcome to Brave Science. Today we're going to talk about string theory. It'll be an introduction to string theory and how quadruplicity can be used alongside string theory. Let's check it out.
Now, Michio Kaku has said that he believes that string theory is falsifiable. Now, when something's falsifiable, it means it can be tested. It means that it can be shown to either be true or false. A claim is made. Does it happen? Well, why hasn't anyone tested it yet? Why isn't it confirmed? The fact that he has to say, he believes it's falsifiable. To me, when I hear that, that means it hasn't been confirmed yet. So what I'm going to be doing is I'm going to analyze string theory. I'm going to read as much as I can about it, and then I'm going to apply quadruplicity to it. According to quadruplicity, this should be here, that should be there, this should work this way. Maybe Kaku will see these videos, maybe someone else will see these videos, tell Kaku, I don't know. But I am interested in that. Look at that, my nose is shining. All of the other reindeer. What I do know about string theory is that it replaces baryonic matter with just strings. There's only one substance in the universe, and it's strings, these vibrating strings. Okay, well, here's the thing though. There has to be 4 parts to that string. Everything else has 4 parts. What are the 4 parts of the string? Let's dig in. See, even when we thought that the atom was as deep as you can go, we found the quarks and the gluons, right? 4. 3 quarks, and then the gluons. So, this string, whatever it is, it's made up of 4, if it is real. And as for the behavior of the strings, it's either cyclic or non-cyclic. Repeating or non-repeating. But there are 4 stages involved in how it interacts. Now, this is actually very interesting because, string theory says that there are only strings, one-dimensional strings. Okay, that's fine, but they got to interact with each other, right? Because, that's what changes. If nothing ever interacts, right, nothing ever changes. So, they should, if it's correct, when they interact with each other, they should proceed through 4 stages, right? Stage 1 would be the initiation of the cycle via stimulation. The stage 2 would be the increase and intensification of activity. There should also be a breaking, a sundering of some sort. And then stage 3 is when, phi comes in, 1.618, that's when a product is made, approximating 1.618. And then stage 4 is, rest. That's the stage with it's identified by a decrease and a de-intensification of activity. And of course, Kaku talks about how, it being like a string, when it's plucked, so to speak, at different frequencies, it produces different sorts of particles. Do you bow it or just pluck it? Most of the time I slap it. All I need to know is the players, the actors in the play. That's all I need to know. Who are the players? And I'll tell you how the play is supposed to go. So that's what I'm doing at this moment. I'm learning the players, the actors in the story of string theory. So what are the things that you need to get sound out of a string? Well, you need a string, for one. You need something to hold it down, hold it in place. Like on a guitar, that would be the nut. You need something to tighten it, to regulate the pitch, right? And then you need something to pluck it. Okay, that's 4 things. And even if you would want to say that, okay, well, plucking it is an outside source, that's alien, so you can't count that. It still works, because then you could say you have the string, you have the nut that holds it down, you have the thing that tightens the string, and then you have all of this connected to some sort of body, some sort of, I don't think the word is apparatus, but some sort of body. Okay, and then what plucks it would be from an outside source. Either way, it's 4. You can't escape from 4. So just go into that. These strings, these one-dimensional strings, what holds them in place? What tightens them? What loosens them? Are they connected to a body, like in the second example, or does some part of that system pluck itself? Like, do the strings pluck themselves? Do the strings pluck themselves, or do they not pluck themselves? That would be the first question. That's what I would look for, including those questions. What holds down the string, what tightens it, and does the string pluck itself? And if it doesn't, how is it plucked in order to, give out the, at that certain frequency to make particles. And that's it for this introduction to string theory. This is Brave Science, telling you to take no one's word for it and be brave. Oh, and one more thing. Go pluck yourself.